Good day, everyone, and welcome to my COS802 project presentation. The objective of this project was to successfully extract any news article that relate to infrastructure in South Africa. I was given the SABC news articles dataset, which contains 38,515 articles and were accumulated between 2020 and 2022. To extract these articles, I used a correlation explanation topic modeling with anchor words to bias the topics towards infrastructure. Infrastructure in this setting relates to any article that contains information about construction, oil and gas, power and renewables, mining and metals, maintenance and improvements, water, etc. After the extractions, I used an LDA topic model to investigate whether the dominant topics in the extracted pool does indeed relate to infrastructure in South Africa. Before I get into what I did for my project, let me just give a brief overview of what the CorEx topic model does. So the correlation explanation model does not depend on an underlying generative model, meaning the model does not aim to learn the underlying patterns and distributions of the data or how documents were written to infer the latent topics. Instead, the model learns from maximal informative topics using an information theoretic framework. The framework starts out by initializing a randomized subgroup of words and a randomized topic, and then finding the correlation between the topic and the subgroup of words. If you've specified multiple topics, the model will iterate over the topics and assign a correlation value between the topic and the subgroup of words for each topic. These values are known as the pointwise total correlation value. Furthermore, the supervised model allows you to infer domain knowledge by implementing anchor words and biasing the model towards the domain knowledge. So I started out, first, the correlation explanation model provides a flexible framework for learning topics that are maximally informative about a corpus of text. So I started out by using an unsupervised CorEx topic model to investigate whether infrastructure was indeed a dominant topic amongst these articles. To my disappointment, it was not, and I had to refer to the supervised CorEx model, where I used a bunch of anchor words and anchor topics. An anchor topic is just a grouping of anchor words. So I grouped some of these words together to find my topics. These words are generally related to infrastructure such as construction, pipelines, oil, water, reservoirs, Eskom, etc. Feeding these words into my model, I used an anchor strength of 15. So to just explain, if you use an anchor strength between 0 and 1, the model refers to an unsupervised topic modeling technique. If you use an anchor strength of 1.5 to 3, you just nudge the topics towards infrastructure. If you use an anchor strength of more than 5, you fully force the model to accept your anchor words. So for an anchor strength of 15, it returned all of the words that I implemented into the anchor words. So for instance, if you look at the output, the first few words would typically be the words that I assigned. So for construction, project, infrastructure, improvement, construction, maintenance, I assigned, and it returned investment, agriculture, poor, budget, refurbishment. Similar for power, I assigned Eskom, power, invest, and it returned plant, infrastructure, utility, shedding, load, electricity, blackout. Once I've assigned these topics, once I've gained these topics, I used that pointwise total correlation to find which article highly relates to infrastructure. I kept all the articles that had a correlation of 0.7 and more. Afterwards, I filtered the data set to keep only those articles and ran an LDA topic model on the extracted data. The unsupervised model then returned topics related to project, department, road, government, engineering, NUMSA, steel, strike, ESCOM, load, power, confirming that the CorEx model did indeed identify articles related to infrastructure, and now the dominant topic is indeed infrastructure. Thank you so much for listening to my presentation.